Hello, we are PreSlice, and we're bringing precision to skin biopsies. Skin biopsies are the standard method to diagnose a plethora of potentially cancerous tumors, but no form of skin cancer is deadlier than melanoma. Every year, nearly 100,000 Americans are diagnosed with melanoma, and every year, over 7,000 Americans die because of it. What makes melanoma so much deadlier is that it spreads incredibly fast to the surface of your skin and can metastasize to the rest of the body within a matter of weeks. Thus, an efficient and accurate diagnosis, and therefore an efficient and accurate biopsy, is essential to saving lives. The most common biopsy method is the shave biopsy, which typically uses a simple razor blade to shave off the lesion. However, while these biopsies are convenient and cheap, which is why they're common, the problem with using a razor blade is just that. Using a razor blade, how deep you cut, how wide you cut, none of it is standardized. The same clinician can extract a different depth each time without even knowing it. And where mere millimeters can determine your fate, leaving behind even just half a millimeter could be catastrophic. Transection occurs when initial biopsy fails to remove the entirety of the lesion. In the image, you can see that significant depth of the tumor remains even after the biopsy. The maximal tumor invasion depth is known as the Breslow depth. Complications in transection has several impacts. First is that it leads to an inaccurate Breslow depth, as shown on the previous slide. As this is the single most important factor in melanoma staging, transections means that the true severity of the cancer is left ambiguous. Secondly, lesions cannot be rebiopsied to gain more accurate Breslow depths because depths can't be guaranteed to be from the same angle or location as before. Without an accurate diagnosis, this can result in upstaging, which is when a patient's cancer is determined to be lower than what it is. So a patient may receive treatment for stage 2, which is what they were diagnosed with, when they actually have a more serious stage 3 and thus need a stronger treatment. This also incurs costs on the clinician side through stuff such as board reviews, in which a multidisciplinary team tries to resolve the issue, which can add up to more than $20,000 per patient for hospitals. While melanomas are the most severe type of skin cancers, transection poses the same issues for all types of skin cancers, with transections occurring in up to half of the biopsies and 5 million skin biopsies occurring every year. It is estimated that 2.5 million biopsies are transected every year, which means that we need a better method for skin biopsies, a method by which we can standardize the extraction of lesions. And that is precisely what PreSlice provides. Our design strives for precision by utilizing a depth control guide that standardizes the shape of each cut, which will reduce transections and in turn lead to faster, more accurate diagnoses. We aim for our cost to be lower than $1 per unit, making us more affordable than any of our competitors. Our main competitor is the dermablade, which was created with safety handles to provide better control over the razor blade, but provides no actual method to control the depth or precision of a biopsy. Our device was devised with those exact factors in mind. Every time we biopsy with PreSlice, we precisely extract the same sample. Our revenue model is as follows. We intend to sell our device as an accessory to the existing gold standard, which is the dermablade, while accounting for all the problems that we highlighted above. We aim to try to break into local dermatology clinic levels at first, which there are about 5K of them, and then hope to build up to academic hospitals and larger hospital systems through word of mouth and conferences and more. We will also sell our devices in boxes of 50 based on our clinician interviews at a rate lower than $1 as mentioned on the previous slide. The timeline for us looks within the next 6 months finalizing the prototype and working on our patent, within the next year entering discussions with medical device companies and sample testing with hospital clinicians, and within the next 2 years building an assembly line and integrating into the workflow of dermatological clinics. This is our team. These are our references, and thank you so much for listening.